When charging system is under 13 volts, you're going to need to test the alternator circuits. So begin by checking for B plus at the battery terminal of the alternator. If B plus is missing or low at the battery terminal, repair the circuit or the fuse link. Now remember, you can measure the voltage drop across the fuse link circuit. Connect the positive DVOM lead to the alternator's output terminal and the negative lead to the battery's plus terminal. With the engine running, voltage drop shouldn't exceed 0.4 of a volt. Now the voltage drop is going to vary with charging rate. Remember, you're doing this with the engine running. The B plus for the field is supplied by the PCM, and that's when the engine is running. The ASD relay is closed. You can't do this test key on engine off. The PCM controls the field circuit, the charging rate, by supplying the ground to the field circuit. So you can start testing at the field's B plus. It should be B plus with the engine running if the circuit is good. If B plus isn't present at the generator's B plus, test the wire between the PCM and the alternator for opens and make repairs as required. If B plus isn't present at the PCM's terminal, go to PCM test. Only after you have tested the field's B plus and determined that it's normal should you continue testing. So we're going to connect a DSO to the field driver circuit and the field B plus. The green arrow at top shows us the green trace. The yellow arrow at top shows us the yellow trace. The field circuit shows a light load in this example, with the field B plus holding normal. Now remember, you're here because you have low charging rate. So if the alternator is not trying to beef up the charging, in this case it's showing a light load, go to PCM test. In this example, the field signal is under a 50% load. We have the same thing. It looks like it's charging real good, but remember, your charging rate is under 13 volts. Go to PCM testing. Now you can see that the signal's grounded 100% of the time. This is the field signal commanding maximum charge rate, and the field's B plus once again is holding normal. The PCM is commanding maximum charge rate and the system voltage is still under 13 volts. You're going to have more data and continue testing the circuits. We're going to do that by adding a low current probe to our other two test leads. The low current probe in our example is the red trace, and we placed it around the field driver circuit. We're going to look at this pattern now. The PCM grounds the field circuit. You can see it goes from high to low there on the bottom, and we only want to see a slight change in B plus, and you can see it's a very slight change. So then field current rises. Now in order for all this to take place, the field current should be 4.2 amps or higher. Now this is normal. We're showing you a normal example here. B plus has to be normal for field current to be normal. So if field current isn't normal, you would look down at the B plus and make sure it's normal before you dump on the computer. The same thing applies. In order for field current to be normal, the PCM must supply a good ground. So the B plus and the good ground makes the circuit so the current can flow correctly. If the field's B plus or ground isn't normal, then you'll go to PCM test, because the PCM supplies both the B plus and the ground for the circuit. If B plus and ground are normal and you still have low field current, the fault is inside the alternator, and whatever your shop does, if it disassembles it and rebuilds it, that's fine if you just replace it, but the problem is inside the alternator. Now here, the field signal remains at zero charge. It's not grounded at any time. Now remember, the problem is under 13 volts charging rate, so the computer's doing nothing for that charging rate. And then you would go to PCM testing when you see that the PCM isn't trying to increase charging.